here I want to calculate the capacitance in the case of a capacitor of parallel plates. You know, in the case of parallel plates, we have two identical plates with a distance between them equals to d. This one has plus q and minus q, so we get a uniform potential between them. The capacitance equals to q divided by delta V. I need to calculate the value of C. I have Q, so we need to calculate delta V. Okay, you know delta V, we can choose 2 points, A and B. We can say delta V equals to minus E dot dx. Delta V between A and B, and dx will be between A and B. So we get like this dx. Okay, so VB minus VA equals to minus AB. You know the angle between E and dx equals to 0. We can write directly minus, and in the case of parallel plate, E is constant. So here we can write E dot dx cosine 0. This one equals to 1. E is constant. We can put it outside between A and B. So we get here minus E integral of dx equals minus E xb minus xa equals to d. Okay, so we can write finally VB minus VA equals to minus E dot D. And you know, delta V is the absolute value of VB minus VA. Okay, so it's equals to E times D. To calculate dV, we have to find E. Okay, this is the most important point. How can we find E? You know, we can use Gauss's law. We calculated E in the case of a plate. So as you see here, I need to calculate the field between the plates. You know, in the case of two plates, I need just the electric field between. I don't care about, anyway, we don't have a field outside. So we can find the field at this point. Okay, it must be constant. You can find at any point here. E is constant. We have to say, first of all, we select a cylinder of radius r as Gaussian surface. You have to say E must be parallel to dA. Second, E must be radial, and E must be constant. Phi equals to integral of E dot dA equals to Qn divided by epsilon. These of the condition to use Gauss's law. Okay? When you write this, we come to solve the problem. Okay. I calculated the field before for a plate. Okay, I can repeat the calculation. First of all, here you have the lateral side. We have the side, let's say here we have side 1, here we have side 2, and here we have side 3. This side is the lateral side. We have E only in this direction. Okay, we don't have a field outside. I don't need the field here. So we can say flux 2 equals to 0. And we don't have a field out in this direction, okay, at the lateral side. So we can say phi 3 equals to 0. We have only phi 1 through this side. On this side, E is constant at any point here. And also we can draw dA, which is parallel to E. So phi 1 equals to integral of E dot dA equals to Qn. Here we have a plate, 2-dimension, okay? We take only 2-dimension. So in this case, I give you sigma is constant, so the charge is uniformly distributed. So sigma is constant, we can put Qn equals to sigma times A. A is the area inside, the area of the charge inside the cylinder. It's here, okay? The area of this one equals to the area of this one. We have the same area, this and this. The intersection between the cylinder and the plate. So we can say E, the angle between dA and E equals to 0. Okay, we can say here cosine theta equals to 1. So EA equals to sigma A divided by epsilon. Okay, I repeat, this value concerns only the cylinder, the side, and this A is the area of the Qn. As you see, the intersection between the cylinder and the plate equals to A. So here we have A, and here we have A, the same A. This one equals to A also. So we can simply eliminate A and A. We get finally E equals to sigma divided by sigma epsilon 0. This is the final answer of the electric field created at this site. Okay, so we can calculate delta V easily. We can say E equals to sigma divided by epsilon. So delta V equals to E times D equals to sigma divided by epsilon times D. I need to calculate C. C equals to Q divided by delta V equals to Q divided by delta V equals to sigma D divided by epsilon. Okay, Here we can substitute the value of Q. You know Q equals to sigma times A. Okay, you can take this value of the capacitance, it's okay, and also you can write the capacitance in terms of A. So we get here sigma A epsilon 0 divided by sigma D. We get let me see, we have epsilon here, sigma and sigma, we get finally epsilon A divided by D. So we can write finally as conclusion, we can say in the case of A parallel plates, E equals to sigma divided by epsilon, first point. Second point, C equals to Q epsilon divided by sigma D, or we can say equals to epsilon A divided by D.